Suppose for this first example, someone can come up with a formula for the power series. So we have -1 to the n plus 1, which means it's alternating, times x minus 5 to the n. So that tells us right here that it was probably centered at 5 because it's x minus 5. And it's all divided by n2 to the n. If we want to figure out where this converges, in other words, which x values this matches the actual function, then we can use the ratio test to determine that. So the ratio test, we're going to do the limit as n approaches infinity, and we're going to do the n plus 1th term over the nth term. And we have an absolute value on all of that. So our n plus 1th term will be -1 to the n plus 2 times x minus 5 to the n plus 1 divided by n plus 1 times 2 to the n plus 1, and that's over the nth term. So -1 to the n plus 1 times x minus 5 to the n over n 2 to the n. We're taking the absolute value of all of that, and we know from the ratio test that this will converge when this limit is less than 1. What we don't know is what happens when it's actually equal to 1. That's the ratio test fails and we have to try something else. So we're going to start looking at this and decide first about the absolute value. So this -1, no matter what power it's raised to, will either be 1 or -1, and the same with this. The absolute value of -1 and +1 is both 1, so they're not changing the value at all, and we know it'll be positive, so those can cancel out. I have to leave the absolute value on for the rest of it because I don't know what's going on with my x. Now I know my n's approaching infinity and starts at 1, so it's always positive, but I don't know about the x, so we leave that. So my next step is to actually simplify this fraction. So this is the limit as n approaches infinity. I'm going to leave the absolute value there, but I'm going to rewrite this as a much simpler fraction. So when we divide by a fraction, we multiply by the reciprocal. So this will stay in the numerator, this will be in the denominator, this will actually be in the denominator, and this will be in the numerator. We turn this fraction over. So in my numerator, I have x minus 5 to the n plus 1 times n and 2 to the n. In my denominator, I have n plus 1 just n plus 1, and then I have a 2 to the n plus 1, and I have an x minus 5 to the n. And again, we know that this converges when it's less than 1. So my next step is to actually simplify the fraction further. So it'll be the limit as n approaches infinity, and I'm going to take this piece by piece. If I look at my x minus 5s, I know that I have one more x minus 5 in the numerator than the denominator, so all but one of them will cancel out, leaving us with x minus 5 in the numerator. My n and my n plus 1 do not cancel out. They're not common factors, so I'll have an n in the numerator and an n plus 1 in the denominator. With the 2's, I have one more 2 in the denominator than I have in the numerator, so I'm going to put a 2 there. And I still have my absolute value, which is less than 1. Now I look at my limit. My limit is as n approaches infinity, so that's affecting the n in the n plus 1, but it has nothing to do with this x minus 5 and the 2, so I can bring this outside of my limit. The x minus 5, I need to keep the absolute value on. The 2, I really don't, because the absolute value of 2 is just 2. So I can say that this is equal to the absolute value of x minus 5 divided by 2, and I'll have the limit of everything that's left. If I look at everything that's left, which is the n and the n plus 1, I no longer need the absolute value because n starts at 1 and goes to infinity. And I want to know when this is less than 1. At this point, you can take the limit. So the limit as n approaches infinity of n over n plus 1 would be infinity over infinity, so you can do dominant terms or L'Hopital's. This limit is 1. So that leaves us with the inequality, the absolute value of x minus 5 divided by 2 is less than 1. If I solve this, I'm trying to figure out for which x values this converges. I'll first start by multiplying both sides by 2. So the absolute value of x minus 5 has to be less than 2. Now the definition of absolute value is the distance from 0. So if I look on a number line, here's my 0. The distance of x minus 5 from 0 has to be less than 2. So I'm going to go 2 out in either direction. So negative 2 to 2. And I know that my x minus 5 has to be inside of that interval. So that lets me know that my interval that I'm solving with is negative 2 is less than x minus 5 is less than 2. To further solve this, I'll add 5 to all pieces. So when I add 5 here, I get 3 is less than x is less than 7. So what I know so far is that if I look at halfway in my interval, that is 5. That is where it was centered. So my center was 5. I also know my radius of convergence. From 5 to 7, that's a distance of 2, and from 5 to 3, that's a distance of 2. So my radius of convergence is 2. What I don't know is my actual interval. The ratio test says that it will converge if this limit is less than 1, but it doesn't say what happens when it equals 1. So what I need to do now is actually determine what happens when x equals 3 and what happens when x equals 7. And we'll do that on the next video.